Welcome back to the lecture series in Circuits and Networks. In today's class, we are dealing about two-port networks. So before going to the two-port networks, what is the concept of such port terminologies? What is the difference between a one-port network and two-port network? So anyhow, this is a common circuit that we are seeing in many examples. Actually, this is a battery that is connected to a resistor and inductor. It is a load connected to the battery. So how many ports are there? Here we are having only one input voltage and one input current. We are giving the response in this port. Okay, and we are observing the response on that port itself. So this is the one and only port that we are having in this circuit. We can draw it like this. This is the network and this is the port. Okay, we are giving a voltage here, current will pass like that. But this is a two-port network. Why? Because this is having one port here and one port here. We can supply some voltage here and we can observe how much voltage is developing across here. When voltage is applied, normally what happens? A current will passes. So voltage is applied and current passes in port 1, whereas I don't know what happens in port 2. I have to measure. Definitely current will not be here. Why? Because this side is open circuit. Now, for the time being, this circuit is open circuit. If I am connecting some resistance here, I am connecting it, then definitely current will pass. Definitely current will pass. So before that, it is if I am removing this, we can tell this as a two-port network. Okay. So load is needed for current to pass in the secondary side or the other side. So here we may be having V1 in the primary side. This is termed as primary side and I1 here. And at this side we may having V2 and I2. Such circuit is known as a two-port network. We can briefly draw it like this. We can represent in such a simple block diagram. This is input port. This is output port. Generally, if plus minus V or V1 is applied here, some current I1 will pass through the circuit. On the other hand, we are having provision to supply voltage from this side also. Or there is two options. Either we can supply a voltage from this side, or we can connect some resistor or some load here. Then also current passes in this side. So generally I am considering as one voltage source may be connected here and other voltage source may be connected here. So here it is V2. The same polarity we have to assume. So the current will be coming towards the network. So this is the standard representation. You have to be careful about the polarity and these arrow marks. I am assuming always this polarity in the standard representation. But in some problems, it may not be like that. It may change. If you are not connecting voltage source and you may be shorting at this side like this. I am just saying an example. You are connecting a current here, giving a source, but on the other output side you may be shorting. At that time the current may be coming in this direction also. That is also possible. If it is a general case like a block diagram, I will suggest you to mark like this, plus at the top side, plus at the top side, and both the current are entering towards the circuit. So this was the actual circuit. This was the actual circuit that I represented here as a box. I will call this as a black box. Why I am calling that as a black box? What is the concept of a black box? I don't know what are the things inside a black box. That is a concept. If I am telling something as a black box, it may consist anything, but I am having some conditions. Inside this black box, I am having some conditions. With that condition, I can permit anything. But what are the conditions? First condition is elements should be linear passive elements. Elements should be linear passive elements. All the elements like inductor, resistor, capacitor are linear and passive. And one more condition is there. One more condition is no source is permitted. No source is permitted inside the network. No source is permitted inside the network. You may have sources outside. You can connect a source at this port. You can connect a source at this port. You can connect a source at this port and you can measure the response at the other port. On the other hand, you can connect a source at this port and you can measure the voltage and current from the other port. All those things are possible, but you can't have a source inside the port. Like, if I am having a voltage source here, is it permissible? No, I can permit a voltage source inside the two-port network. It may be having at the ports, but I can permit it inside. So this is the brief concept about two-port networks. Now we are going the first parameters of two-port network, that is set parameters. So now we are discussing set parameters. Actually, what is set? Set is impedance. Impedance means the net opposition offered by a AC circuit against its current flow. In terms of DC, we can write it as V is equal to IR. In terms of AC, we are writing V is equal to I into Z. Okay. So Z is equal to generally V by I, or V is equal to IZ, or V is equal to IZ. This one we are generally using, where Z is equal to impedance. Z is equal to impedance. V is equal to I into Z. Anyhow, for a network, we can represent voltage as a function of current. That is, V is equal to I into Z means voltage is a function of current. What is that function? Function is just current into impedance. So anyhow, for a circuit, voltage is a function of current. Now let me introduce about two-port network. Set parameters is going to be discussed in case of two-port network. So it is a two-port network where we are having two ports. One is a input port and other one is a output port. In input port, suppose we are having a voltage V1. We may be having a current I1 going towards the circuit with plus polarity here, minus polarity here. On the output also, we can connect a voltage source and we can supply a current towards the network. This is the case. Now here we are having two voltage, V1 and V2. So generally V is a function of current I. V1 is a function of, V1 is depending on I1 only. If I2 changes, that also depends on V1. And V2 depends I2 and I1. Because this is a circuit inside. As we already checked, this may be a circuit like this. Now we can easily say this voltage depends upon this current and this current. Like that. And the vice versa, this voltage depends upon this current and this current, like that. So anyhow, voltage V1 is a function of both I1 and I2, and voltage V2 is a function of, similarly V2 is a function of both I1 and I2. So what is the relation between voltage and current? We can relate voltage and current in terms of impedance. So let me write V1 is equal to some z into I1. Now this relation is over, and it's also depending on I2 plus some z into I2. This z and this z will be different. This is marked as Z11 because V1 and I1 are getting related, and this z should be marked as V1 and I2 are getting related, so it should be marked as Z12. On the other hand, what about this function V2? V2 is also a function of I1 and I2. So V2 is some I1 plus something into some I2. What is this something? We know voltage is current into impedance. So this is also some z and this is also some z. What will be the name of this z? It is relating V2 and I1. So it is Z21. And this z is relating V2 with I2. So we can mark as Z22. This is very important. This is very important. On the other hand, I can write this as matrix form. I know now you are very familiar with matrix forms. You know how to do Cramer's rule, how to arrange equation in matrix, everything you know well. So let me write easily Z11, Z12, Z21, Z22 into what is there in this matrix? I1 and I2. Is it okay? V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. It's okay. So this is the representation of Z parameter, and this is the Z parameter matrix. Z parameter matrix. Now how we can find the value of each one? Z11, Z12, Z21, Z22. Okay, that is also very easy. We can do from the equation itself. Now I am going to that. Okay, we know that V11 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. Now we are going to make not secondary, I am not using that term. We are going to make I2 is equal to 0 or open circuiting port 2. So what will be the figure? This is the network. Okay, this is the network. We are having a source. I am connecting a current source, current or voltage source, whatever. I am connecting here. So current I1 will be there, and we may get plus minus a voltage V1 here. On the other side, this terminal is open circuited. OC. What is OC? Open circuited. So I2 is equal to 0. Now rewrite our equations. Our equation will become V1 is equal to Z11 I1 plus Z12 I2. In that I2 is equal to 0. So V1 is equal to Z11 I1 plus 0, and V2 is equal to Z21 I1 plus 0. Okay, so what was the condition? We are open circuiting port 2. Please remember that. Now let me write what is Z11. Z11 is equal to, from this equation it is V1 by I1 at I2 is equal to 0. Is it okay? This is the condition and this is the equation. And this Z11 is known as open circuited input impedance. Is it okay? Open circuited input impedance, because you open circuited the secondary side, and this is nothing but V1 by I1. Both V1 and I1 are at the input side. So this is the impedance of input side, V1 by I1. That's why we are calling it as open circuited input impedance. Now from this equation, let me write Z21 is equal to V2 by I1, where what is the condition? I2 is equal to 0. Now tell me, it is not purely on input side or output side, because voltage is on the output side and current is on the input side. So what will be the name of Z21? Anyhow, what is the condition? Condition is same, open circuited. Okay. Then this is anyhow an impedance, but it is not input impedance or not output impedance. So we can write it as a transfer impedance, because from primary side to secondary side, it is showing some relation between I1 side to the secondary side or port 2. So it is known as transfer impedance, open circuited transfer impedance. But there is something is missing, because where we are connecting the source is connected in the primary side or the port 1, and we are injecting a current towards port 2, or we are supplying voltage here. Okay, voltage here. Where is the V2? Let me ask. Anyhow, the secondary side is open. So I2 0. Even though I2 is 0, we may get some voltage. Across open circuited terminals, current will not pass, but there exists a potential difference. Voltage is there. If you connect some lamp here, it will glow if potential difference is there. So V2 is present. Even though circuit is open circuit, V2 is present, but I2 will be absent. So this circuit is having voltage. So we are supplying from primary side and measuring from the secondary side. This criteria is known as forward path. So what is the name? Open circuited forward transfer impedance. So Z21 is nothing but V2 by I1 at I2 is equal to 0, and its name is open circuited forward transfer impedance, because source is connected in the port 1. Okay. Now we are going with the other side. Initially we made secondary side or port 2 open circuit. Now we are making port 1 open circuit. Port 1 open circuited. What is the condition? This was the figure where I am making port 1 open circuit, and I am connecting a voltage source or current source in the secondary side or port 2. If it is a current source, it will inject a current, and based on that voltage will be here. Or if it is a voltage source, I have to connect a voltage source V2 like, and there also current I2 will pass like this. So both are correct. You can connect a voltage source or current source. Here I am connecting a current source I2. Regarding that, V2 is developed, and this is the network. As V2 is there, we will get some voltage V1 here, but I1 should be 0 because it is a open circuited condition. Now we have to rewrite these equations. V1 is equal to, as I1 is equal to 0, it is 0 plus Z12 I2, and V2 is equal to 0 plus Z22 I2. Okay, now I can write Z12 is equal to V1 by I2 at, what is the condition? I1, port 1 current should be 0 or open circuit. So what is the name of Z12? It is neither output impedance nor input impedance, because it is relating V1 and I2, cross relation is there. So definitely first we have to write the condition. What is the condition? Open circuited. Some terminal is open circuit. open circuited, as it is representing a cross relation, we have to use the term transfer. Not transfer initially. Before that, we have to use forward or backward. Open circuited transfer impedance. Why transfer? Because it is representing cross relation V1 to I2 or secondary side to primary side. So transfer impedance we have to use. And is it forward or backward? Please look the figure. Source is connected in the back side. So it is backward transfer impedance. Open circuited backward transfer impedance. Now from this equation I can write Z22 is equal to V2 by I2 at, what is the condition? I1 should be equal to 0. And what is the name of Z22? Z22, don't get confused, it is only relating between V2 and I2. So it purely represents the impedance of the secondary side or output impedance. And we have to mark one more thing. Is it open circuited? Yes, we have to write it as open circuited output impedance. Open circuited output impedance. So now we arranged all the matrix elements in the relation of V1, V2, I1, I2, etc. Z11 defined, Z12 defined, Z21 is defined, Z22 is defined. All the 4 parameters are defined and the conditions are defined. How we can find these parameters, that is also well defined. Now we are moving to a small problem regarding these Z parameters. This is the question. This is a simple two-port network. The question is find all Z parameters, that is Z11, Z12, Z21, Z22. Initially, I will tell you one thing. Don't expect such questions because such easy questions will not appear in exams. But this is anyhow for you to understand what is the exact deal with these parameters. That's why we are discussing it. Okay. For that, this is the standard equation. Z11 I1 plus Z12 I2 equal to V1 and Z21 I1 plus Z22 I2 is equal to V2. Anyhow, initially we are making I2 equal to 0. Okay, I will write here. We are making I2 is equal to 0 initially. For that, I will write the standard equation and I will write the equation that derived from the problem on the right side. What is standard equation when I2 is equal to 0? Z11 is equal to V1 by I1. On the other side, in this problem, if you are taking I2 is equal to 0, then what happened? No current will be passing in this loop. So that the one and only current will be I1. Okay. So what will be the equation? I will draw it here. This will be the circuit. When I2 is equal to 0, this will be the circuit. V1 is connected and current will be I1 and this is the circuit. The other area will not exist because no current is passing through this resistor. I can eliminate this area. So this is the circuit. So from the circuit, if I am applying KVL, I can write it as plus minus. I can write it as, this is the direction. So minus V1 plus 1 into I1 plus 2 into I1. that is equal to 1 plus 2. 3I1 is equal to V1 and V1 by I1 is equal to V1 by I1 is equal to 3. Here I know that V1 by I1 is equal to Z11. So what is the answer? First answer, Z11 is equal to 3. Okay. Now one more thing is there. We have to calculate next thing. From second equation we will get that when I2 is equal to 0, when I2 is equal to 0, Z21 is equal to Z21 is equal to, yes, tell me. Z21 is equal to V2 by I1. This is also the same thing when I2 is equal to 0. And in the problem, I want to relate between V2 and I1. How I can relate between V2 and I1? Actually, where is V2? This is the V2. And we know that no current is passing through this resistor. So, the same V2 will appear across this. If current is passing through this 3 ohm resistor, some current into resistance, voltage will get lost. A loss will be developed, a drop will be developed here. But in this case, no current is passing as I2 is 0. So, we can tell V2 will be the voltage across this terminal. So, this is V2. So, please relate V2 and I1. So, this is the current I1, this is the current I1, and that current I1 passing through the 2 ohm resistor will create V2. So, V2 is equal to 2 ohm into I1. So, we want V2 by I1. V2 by I1 is equal to 2. Very simple. So, what is the answer? Z21 is equal to 2. So, before writing the answer, you can write like this. This is equation 1 and this is equation 2. By comparing 1 and 2, and here you can write this is equation 3 and this is equation 4. So, by comparing 2 and 4, sorry, not 2, 3 and 4, you get Z21 is equal to 2. Okay, now we are coming to the other side of this problem. In this side, we want to make I1 is equal to 0. So, I1 is equal to 0 means what will be our new equations? The first equation will become V1 is equal to Z12 I2. So, Z12 is equal to V1 by I2. This is equation number 5. And in our problem, it is you want to make I1 0. So, source is connected at this point. Plus minus. And this current I1 is equal to 0. Open circuit. You have to redraw like this. You have to redraw in your page like this. Don't alter in the question. Please redraw. So, if you are drawing an equivalent circuit, V2 plus minus 3 ohm and 2 ohm. And where will be V1? This voltage will be V1. And as current in this resistor I is equal to 0, the same voltage will appear across this terminal. This is also V1. Now, okay. Now I am marking V1, V2 and I2. How I am marking I2? You cannot choose any arbitrary direction for I2 in such problem, because if you are taking V2 with this polarity, then I2 should be on this polarity. So this is the polarity of I2. So that this will become plus minus plus minus. If you are taking a loop direction, then definitely your loop direction should be this, if it is a loop current. Otherwise, you can just take any arbitrary direction. If you are taking this direction, let me write, it will give you, okay, we will write this KVL equation later. I will write both the options, because now we are translating V1 and I2. For that, this current relation is needed. This is the I2. So 2 into I2 will give you V1. It is also plus minus. And the I2 is entering at positive terminal, so no sign change. 2 into I2 is equal to V1. So V1 by I2 is equal to 2. This is the equation number 6. So by comparing 5 and 6, we will get Z12 is equal to 2. Now, let me write KVL. Before that, if you are making I1 is equal to 0, then from the second equation you will get V2 is equal to Z22 I2 and Z22 is equal to V2 by I2. So I want to translate V2 and I2. So I am writing the KVL. So you can write the KVL in clockwise or anti-clockwise. But the polarity of each component should be marked based on the direction of this original I2 current. So if I am tracing the KVL in the direction of I2, then I will get I2 direction is anti-clockwise. Minus V2 plus 3I2 plus 2I2, that is equal to 0. That is 5I2 is equal to V2. 1 minute. If you are writing KVL in opposite direction, then you will get minus 2I2 minus 3I2 plus V2 is equal to 0. Then also you will get the same result. So 5I2 is equal to V2. So that V2 by I2 is equal to 5. This is equation number 7 and this is equation number 8. By comparing 7 and 8, you will get the answer Z22 is equal to 5. Okay. So you will get some important conclusion. Z11 and Z12 are different answers, but Z12 and Z21 both are same answer. 2 is the answer. That is, it is a reciprocal network. It is a reciprocal network. Please memorize. Please keep the term in your memory. Reciprocal. Z12 is equal to Z21. Then it is a reciprocal term. So one and only thing you should be very careful is how to mark the direction of polarity of each components. Then you have to take, if I2 is equal to 0, you have to concentrate on direction of I1. It should be coming from the plus. So it should be in the first network, it should be plus minus and plus minus, and it is V. So what will be the KVL? Minus V plus I1 into R1 plus I1 into R2. In the second equation, you have to check that the direction of I2 is given as this. Then mark the polarity based on that. Otherwise, if you are taking just like mesh analysis, your answers will be wrong. Because it is not mesh current. This direction is not mesh current. It is just direction for applying KVL, a trace, not mesh current. Current is original direction of current. Based on that, you have to mark plus minus. Then you can apply KVL in this direction or that direction. That is same in both the way it is same. Okay. So hope you enjoyed this video. We'll see you in the next class. Thank you.